Hey, hello everyone. Let's discuss weekly contest of today. So in the first problem, we are given an integer n. We need to form a new integer x by concatenating all the non-zero digits of n in their original order. If there is no non-zero digit, then x is equal to 0. At the end, the sum is defined as sum of digits of x, and we need to return an integer representing the value of x into sum. Alright. So what the problem says, like this is the number 10203004. Remove all the zeros and concatenate the remaining digits. So it gives us 1234. Alright, all zeros are removed and the order is same. Now take the sum of all the digits of x. So 1 plus 2 plus 3 plus 4, which gives 10, and return the product of this x and the sum of its digits. So what do we want? We want x first of all. So let's just convert our number to string. Right. Now create a new string by just, let's say x, or let's say temp, by just removing the zeros. Iterate over st. If the current digit is not equal to 0, push it back in temp. Alright. Now what is x? X is 0 if all the digits are 0. Okay. And if all the digits are 0, temp will be empty. And if temp has something, x is equal to that number. Alright. So we have x. We need to count the sum of digits in x or temp, let's say. So iterate over temp. And add the current digit. Alright. Now we need to return sum multiplied with x. Note that it can go up to long. So just initialize both of them as long. Alright. So this got our solution accepted. Now let's move to the next problem. So in this problem, we are given an integer array nums. We need to return the length of the longest subarray that has a bitwise XOR of 0 and count all the equal numbers of contains all equal numbers of even and odd numbers. If no such subarray exists, return 0. Alright, what the problem says. The problem says that we need to count, we need to return the length of longest subarray such that subarray satisfies two conditions. The first condition is XOR is 0. Alright, and the second condition is count of odd and even is same. And we want the longest such subarray. So let's see what we can do. In the first example, we have 31320. Let's for each index, we check whether such a prefix exists or not. If it does, what is the longest length of such prefix? All right. So for 3 is the first number. So if we take XOR of 3 with this particular, or let's say I minus 1 a digit, that is no digit, the overall XOR is 3. All right. So it is not a desired answer. Similarly, for 1, XOR with 3 gives 2, which is not a desired answer. Similarly, for this 3, no particular prefix exists. For this 2, if we take the XOR, 3 XOR 3 is 0 and 1 XOR 2 is 3. Alright, so this is not a desired answer. But if we take XOR with the first index, that is XOR of this particular subarray 1, 3, 2, then the XOR is equal to 0. Alright, and what are the count of odd and even digits? Odd is 2 and even is 1. So this is not a desired answer. But if we take a subarray from 1 to 4, alright, the XOR is 0 and the count of odd is 2 and the count of even is 2. 0 is the even number considered here. Alright, so the what is its length? Its length is 4. So that will be our answer. So let's understand the concept. Alright, if we want if we want first condition to be satisfied, what was the first condition? XOR should be 0. This is a very famous problem for XORs. That is, if we want to find a subarray, if we want to find the XOR of a subarray, we can say that prefix, okay, XOR from L to R is equal to XOR from 1 to R XORed with XOR from 1 to L minus 1. Alright. And we want this particular XOR from L to R to be 0. So when will this be handled? So if we know that A XOR A is equal to 0, that is, if we XOR a number with itself, it gives 0. So this particular thing and this particular thing and this particular thing should be equal to 0. Alright, for the overall XOR to be 0. So we realize that XOR from 1 to R is equal to XOR from 1 to L minus 1. Alright. So first condition is satisfied. If we want indices of first condition satisfied. Alright. Then, okay, if we have a index I and we want the smallest index j that satisfies this condition, then we have I, we want smallest j that satisfies this condition. Then prefix XOR of R, let's say I, is equal to prefix XOR of j minus 1. That okay, for the smallest index j. What about the second condition? The second condition says that count of odd and even should be same. Alright. So can we just represent this particular condition in this same form? That is, something appears in left side, which depends on ith index, and something appears on right side, and it appears in j minus 1th form. So let's try to create such a function. Okay. If we say we take the difference of count of odds and count of events in prefix of I and j. What would it mean? Alright, let's say count of odd at j I minus count of even at I. Similarly, count of odd at j minus 1 minus count of even at j minus 1. What if these two values are equal? What do it represent? Count of events from 1 to I and count of odds from 1 to I. Alright, from index 1 to from index I. What does this mean? If these two values are equal, it means that the count of odds from, okay, so just do some swappings, like let's say from 1 to I minus count of odd from 1 to j minus 1. Alright, and count of events from 1 to j minus 1 minus count of events from 1 to I. Okay, so what do we want? We want that the count of odds from I j to I, that is count of odds from 1 to I minus count of odds from 1 to j minus 1. This gives us count of odds from j to I. Alright, this should be equal to count of events from j to I. Even count of events can be represented in this form. Okay, if we just do some computations so that it matches the upper thing, that is both I are on one side and both j minus 1 are on one side. So we say count of odd from 1 to I minus count of even from 1 to I is equal to count of odd from 1 to j minus 1 minus count of even from 1 to j minus 1. And from 1 to I can be said as prefix. Alright. Then prefix of odd from 1 to up to I minus prefix of even from 1 up till I equals prefix of odd up till j minus 1 minus prefix of even up till j minus 1. If we create a prefix of odd minus even, alright, then prefix odd minus even, alright, up till I equals to prefix odd minus even up till j minus 1. Alright, and these two things matches. So we can just create a pair, and for each index I, we want to find the first index which matches the pair prefix or comma prefix odd minus even. The first index that matches is the one that gives us the largest subarray ending at index I. Alright, match the pair prefix XOR, comma, prefix odd minus even for each index to find the largest subarray ending at that index. Alright, and at the end, if we find a matching value in a map or a set, then create a answer and try to maximize the answer for each such indices. So let's try to implement it now. Okay, so let's create what we needed. We needed prefix XOR for n elements. And what did we need? prefix odd minus even for n elements. Alright, let's create it. For prefix XOR, let's XOR the previous element with current element. For prefix odd minus even, check if the current element is odd, then add 1 to the previous value. Else, subtract 1 from the previous value. Alright, now create a map, keep iterating from first index up till n. Now also keep a answer value. If we find the same value, that is, we find same prefix XOR and prefix odd minus even, then maximize the answer with the current max value. The map is not actually int comment, it's pair int comment comment. Alright, and if it is not found, just initialize it. Alright, at the end, return the answer. So this is it. So this got our solution accepted. Let's move to the next problem. So this problem is same as the previous problem where we were given a string s of length m consisting of digits, but here instead of finding the value of x into sum for the given number, we need to find the x into sum for a given range. Alright, because we are given a string, let's say 10, so we are given a range from li to ri for many queries. Let's say this was the range given to me, so this substring becomes our new number now, and we need to find the value of x into sum for this given string. All right, so what to do now? All right, let's understand. So let's say we had this string, for example. All right, so first of all, let's remove all the zeros, because what x will be created does not have zeros. Now we want the answers from range L to R. Alright, many ranges from range 0 to 7, range 1 to 3, range 4 to 6, and so on. Alright, so since we have created a X array of this string we were given. Alright, so now the index shifting has appeared, that is 0 was on index 1, 1 was on index Okay, 1 was on index 0, 0 was on index 1, 2 was on index 3, 4 had 0, 5 had 3, 6 had 0 again, 7 had 0 again, 8 had 4. Now what has happened? Now in X, this 1 has 0 as same, but 2 has 1 instead of 3 as its index. Similarly, this 3 has 2 instead of 5. Alright, this 3 was having index 5 in ST and index 2 in X. And this 4 is having index 3 instead of 8. Now let's say we were asked to find the answer for this subarray. Alright, okay, let me write this down. We had 1, 0, 2, 0, 3, 0, 0, 4. Alright, and we converted it like this. Now, if we were asked to find 1, 2, 3, 4, 5, 6, 7. Alright, if we were asked to find the answer from range 1 to 6, alright, what is the corresponding value in X? It is from 2 to 3. So, how do this change in index or mapping of index take place? Alright, so let's say we were asked for L to R in string st. Now, what index do we need in X? Alright, 0 belongs to index 1 here, and the first number after uh, this 0 is this 2. Alright, and this 2's index here is 2 and in X is 1. Alright, so the first number that appears after our first 0. Alright, take its index, find its mapping in the new X, and that is our new starting point. Mapping of first non-zero after L. Similarly, mapping of first non-zero, not after but before R in X. This is our transformation of or mapping of index for given range L to R. We needed to find our answer. So we need to find the new X, and the new X transforms from range 1 to 2. Alright. And how? Mapping of first non-zero number after L, comma, mapping of first non-zero number before R. But even now, even if we have still found that we want the value from index L1 to R1 in X. Alright. So how do we find the value from L1 to R1 in X? This is still a problem here. So how do X actually appear in number system? We can say X is like 1 into 1 plus 2 into n plus 3 into 100 plus 4 into 1000. Alright, basic number system. Because we are using 10 based indexing, so first digit is multiplied by 10 to the power 0, second digit is multiplied by 10 to the power 1, third digit is multiplied by 100, and similarly so on to get this X. Now, if we want index 1 to 2, alright, these two values, then how would we say we get this value? We say we want 2 into 1 plus 3 into 100, 3 into 10. So what do we do to get these two values as our new x now? Alright, what we can do? Can we write it like this? Like prefix of R1 minus prefix of L1. What did this gave us? This gave us 2 into 10 plus 3 into 100. Now still it is one shifted in order. Alright, we want this 2 should be multiplied with 1 and this 3 should be multiplied with 100. So just divide it now because it is shifted by 10. Divide it by shifting amount now. If we divide it by shifting amount, we get what is the shifting amount? It is equal to 10. So we get 2 into 1 plus 3 into 10, what we demanded. And what extra do we want? This is our x that we wanted. Alright, because here we want the product of sum and x. So we have found x now. Now we want sum. Sum is quite simple because uh, if we want sum, we can just have prefix sum. Alright, we now want the sum of digits from index 1 to index 2. So have a prefix sum for it. Alright. Alright. So we have x now. We have sum now. What do we want? We just want x into sum. Alright. And this gives our answer. So what time complexity did we require? Mapping. Mapping can be done using maps. And what would be the time complexity? Log n. So just create a map. Map could be created in n log n. That is mapping of each index to the new index in X. Now we want to create this prefix value. All right, prefix value is like the value of this X string in the form of normal uh, decimal system that we write, that is 1 into 1 plus 2 into 10 plus 3 into 100 plus 4 into 1000. What do we need for it? We would just iterate over this whole string. So creating this number system and this prefix would require O of n, and in O of 1 we can get prefix of R1 minus prefix of L1 minus 1. All right, and just dividing it, what do we divide by? Divide by shifting amount. And shifting amount is what? Let's say we are at currently index uh, 1. We want to shift it by 1. All right, so what index we are currently at, that is the amount we want to shift, because if we started with this 1, we did not need to shift it. All right, because we started with this 2, we need to shift by 1. If we had started with this 3, we need to shift it by 2. So it is just a division operation. It can be performed in O of 1, and this prefix sum finding can be done in O of 1 as well. So overall, each query can be resolved in O of 1. All right, but what do we need now? We also have modular arithmetics because this cannot be computed. So modular division can be performed in log n. So overall complexity, like modular division, if you don't know, you can study this topic because we need binary exponentiation for this. So it can be done in log n, and this is the highest complexity required to resolve each query. So each query is resolved in log n. All right. So let's go on and implement this thing. Okay, so let's create the string x now using s. X is empty initially. Now what do x contain of? Contain of non-zero digits. Alright, if the current digit in S is not equal to 0, just push it in X. Now what do we want? We want a mapping for starting index of range and ending index of range. Alright, so for starting index of range, we want the next non-zero digit. Alright, and ending we want previous non-zero digit. So let's implement it. Alright, so we want the next matching or next non-zero digit as the starting index and previous non-zero digit as the ending index. So we just assigned j with the last possible value of x indices. Then if we find that it is not equal to 0, then move to its corresponding index, and if it is equal to 0, keep j as it is and then assign starting index as j. Similarly for ending index. Now about the vector of prefix and prefix sum. Okay, let's assign m as the size of x. So we want prefix and prefix sum of size m plus 1. Alright, just keep in mind that x is currently 0 based and prefix sum are 1 based. Also, the queries are 0 based. Right. So let's write the code without modulo right now, and at the end we will apply modulo. Okay, since x is 0 based, what is pref of I? Pref of I is pref of I minus 1 plus current digit. What is the current digit? It is equal to x of I minus 1 minus 0 multiplied by its corresponding power. So power is 10 comma I minus 1. Alright, because it is 0 based. What about the prefix sum? Prefix sum will be equal to prefix sum of I minus 1 plus the current value of x. Alright, so we got our prefix and prefix sum. Now resolve all the queries. Okay. It is in a form of vector of int. So L is as it of 0 and R is as it of 1. It is 0 based indexing. Alright. So what is the mapping L1 and R1? Starting of L. And what is the mapping R1? It is ending of R. There can be a edge case that is we are given only 0 endings at the starting. Alright. So like 1000. We need to find the answer for this. So starting will be equal to this particular index, that is the ending index, this particular index, and ending will be equal to this. So it is an invalid range. Alright. So if the range is invalid, that is if L1 is greater than R1, just push 0 and no need to compute. Alright. What about the other part? Alright. Now we need to compute the answer for this part. Let's say answer is 0 right now. So what should it be? It should be prefix sum multiplied by prefix value. We have the range from L1 to R1. Alright. So what is sum right now? Sum is equal to prefix sum of, since it is one based indexing, R1 plus 1 minus prefix sum of L. Alright. Just remember that it is one based. So that's why plus 1 here. And what about the value of x? Let's say it is val. It is equal to prefix at r plus 1 r1 here L1. Right. R1 plus 1 minus prefix at L1. But here it is shifted right now. What, by what amount should it be shifted backward? It should be shifted backward by L1. Alright. Alright. So what do we need to do now? Just push val into sum in our answer, and at the end return answer. Should it work now? No, it should not. We should apply modular arithmetics now. What do we need? We need power, we need division operator, and we need multiplication here, addition here. So let's do it now. Okay, so something wrong that we did was assuming that, not actually assuming, it was writing 1 2 3 4 like this. Actually, it is 4 into 1 plus 3 into 10 plus 2 into 100 plus 1 into 1000. All right. So now if we want to, if we are given 2 3, all right, what is the shifting to be made? Okay, we have it in the form of 3 into 10 plus 2 into 100. So what is the shifting to be made? Shifting is made to be of 10 again, and what is it given by? It is given by the number of indices or number of elements present after this 3. All right, that is the number of powers we need to shift by. So this is the same, and the same code after applying modular arithmetics, like we calculated the raw value here and then shifted it by m minus r1, that is minus 1, that is the number of remaining elements, and then temp is calculated and pushed into answer, and this got our solution accepted. So thank you all for joining us. All the best for next contest.